Going back. So let's look at anything else before we look at, so let's choose one more example before I show the definite integrals.
I have a question though.
Yes, yes.
And I think someone else was going to ask this, but so these are all giving us like dy is always being able to be like plugged in exactly.
No,
What
not
about,
necessarily.
yeah, can we do an example where it's not?
Yeah.
Like,
yeah. In which some adjustment has to be made.
yeah.
Yeah. So for example, 20. Yes. But the adjustment has to be minor, has to be a constant. It cannot be x or y squared or something like that. Those are other techniques of integration in which more sophisticated steps are required. Okay, so let's look at 20. So you see a different one. So I think I'm on page 8, yes. I have to put them in order and label them because if I drop them, then I need more time too. So 2 plus 8x dx, and of course, x cannot be negative 1/4. Perfect. And then I would like to look at one with exponential or something like e to the x. And then I'd like to show the definite. Good. So the steps are exactly the same. I will denote y by this, 8x plus 2 is denoted by y. Let this be y. You will say, okay, of course, you will say 8 dx. But now there is a problem, right? I don't have that 8. Oh, that's not a problem. Because I can multiply by 8 and divide by 8. That's 1. I'm not changing anything. There is no problem there. So when I continue, I will say I have 1/8 in front because this one will be used for dy. So again, I have dy over y. Same thing. So this becomes the y because I already denoted 8x plus 2 by y. I have 8 dx in the numerator, but there is 1/8 that has to be brought outside. So that's the only adjustment. So I still have the same thing plus a constant c. And I put that in. So natural log the absolute value of 8x plus 2 plus a constant c. So the adjustments have to be minor, a constant. Multiply and divide. If I multiply and divide by 8, I didn't do anything because this is 1. But I broke it so that 8 and dx are together in the form of dy, and 1/8 now it's brought outside. And remember, these are always easy because if you differentiate this, you have to get this function. So it's always easy to check. So let's look at one with exponentials. Like 17, for example. Let's look at 17. So we have the integral from t squared minus e to t squared times e to negative t to the third dt. So if I ask you what is the problem now, I know you're not going to say t squared. That's a friendly function. I'm sure you're going to say e is a friendly function, but I really don't like this inside e. That's the problem. I like t squared. I like e to the x or e to t, but I don't like e to negative t cubed. So that's my u or y, negative t cubed. As long as I can find dy, even if it needs a tiny, tiny tweaking, it's okay if it's a constant. So can anyone give us dy? Anyone?
T squared.
There is a negative. Yes. 3t squared. It's not good enough. Dy has to have something else.
Times dx.
E.
dt because we are talking about t this time. Here it has dx because we are talking about x. When we talk about t, we have to use dt. Okay, So here's another little tweaking. So no problem here. This is e to y. No problem here because I have t squared dt. But I am missing the -3. So I will multiply by -3 and divide by -3, which makes no problem because this is 1. So it creates no problem. But the -3 with t squared and dt, -3 t squared and dt will be replaced by dy. And this is e to y. E to y, -3 from the top with t squared, with dt, this, and this are replaced by dy, and e to -t cubed is e to y. No problem, -1/3 e to y plus a constant c. And now I plug it back in. I have to present the final answer in the variable that it was given to us. So e to -t3 cubed, -t cubed plus a constant c. So once you start practicing this and redo the problems we do in class, it will become second nature, the substitution rule. Let me, hopefully I can show an example. I still have time, right? What time? Yes, 4 minutes. Okay, let me show an example with a definite. Slightly different. You'll see in a moment why. Not difficult at all, but slightly different. Okay, so let's start with 47. So we have the integral from 1 to 2, from x squared minus 1 to the 7th power dx. Everything the same as we just did it. Of course, I'm going to use the same y to make my life easier, x squared minus 1. I know you're going to say that dy equals 2x dx. And I know you're going to tell me you don't have the 2. Okay, no problem. The 2 I can always make up. 2/2 is 1. I know you're going to say write 1/2 in front. Don't copy the limits of integration. Be careful now. This is y to the 7th. 2x dx. 2x dx is dy. But now I have to stop and create limits of integration for y. When I plug in 1 here, 1 minus 1 is 0. When I plug in 2 here, I have 4 minus 1, which is 3. So understand that these limits are for x. X is in between 1 and 2. But y, when x is 1, y is 0. When x is 2, y is 3. So for the definite integral, I cannot copy the limits of integration. I have to determine limits of integration for a new variable that I just created. I created this. It's based on x. When x goes from 1 to 2, y will go from 0 to 3. So now this is 1/2 y to the 8th over 8 from 0 to 3. We do not go back to x. X is gone. So 1/16, 3 to the 8th power minus 0 to the 8th power, and this is the final answer, whatever that is, 3 to the 8th over 16. Because the answer is a number, there is no need to go back. Please don't go back. So what is the difference between the indefinite and definite? We don't go back. The answer is a number. When I changed from the integral in x to the integral in y, I copy new limits of integration. I cannot copy 1, 2 for y because 1, 2, between 1 and 2 are for x, not for y. So do I have time to work on one more? I know I have 1 more minute. I can stop, you choose. It's up to you. We can stop. So that's the only difference. Yes, go ahead.
how we can differentiate between X and Y? So,
What do you mean between X and Y? I'm not sure. I understand the question. Tess.
no, you just say we don't use the X limits for the Y's.
But you cannot, because this is y equals x squared minus 1. When x is 1, y is 0. When x is 2, 4 minus 1 is 3. So these are the
Oh,
limits
we
for x. You cannot copy the same
Yes.
limits here. You created something in terms of x. You have to find the limits for y. So when the limits for x are between 1 and 2, the limits for corresponding limits for y are between 0 and 3.
Okay.